Morning, ladies and gentlemen. Welcome to your video notes for Chapter 2, Section 5. This is actually Part 2 of the notes for this section. Remember that Chapter 2 contains a lot of information. So this particular lesson spanned a couple of days, so it will also span a couple of videos. And these videos will cover graphing rational functions. So up to this point, the first part of 2.5, the first set of videos for this section, involved graphing only reciprocal functions because that was a review item. So up to this point in this section, we've been graphing rational functions that fit that description, that have the parent function that is the reciprocal function. Every single one of those problems had two things in common. The denominator was always x minus h. We never had a quadratic or a cubic or anything larger on for the denominator. And we always ended up with a integer, a number in the numerator, or we could divide to get an integer. Okay? So in that case, those were relatively simple examples. We're going to be talking in a lot more detail in this set of videos about rational functions in general, where we're talking about a function that is the quotient of two other polynomial functions. Okay, so that's what we're going to be dealing with in this set of videos. We're going to be dealing with problems like y equals f of x over g of x, where f of x and g of x are both polynomials, and of course g of x is not allowed to equal 0 because we cannot divide by 0. So down at the bottom of this page you'll see three examples of the types of functions that we're going to be dealing with, the examples of rational functions. The first one is just a simple reciprocal function. All of the rules we talk about today would apply to that function as well. The second one, we got a quadratic on top and a linear on the bottom. Then the third one, we have a quadratic on top and a cubic in the denominator. All three of these are rational functions. That's what we're going to be talking about graphing in this set of videos. So the big ideas here, the way that this works for the most part is a 6-step process every single time. We're going to start off by identifying vertical and horizontal asymptotes. There is later on there in step 4, there's actually a caveat to vertical asymptotes. Sometimes those values are not asymptotes, they're holes. So we'll learn how to check for that later. Then after we get the asymptotes graphed, we will make a table of values, check multiple values from each section of the graph, divided up by those vertical asymptotes, and we will then sketch that graph. Now there are more advanced details we'll talk about as well in later videos. Again, sometimes the numbers we think are vertical asymptotes are actually holes. We'll talk about how to find those later in this set of videos. On occasion, we won't have a horizontal asymptote. We'll have what's called an oblique asymptote, and we'll talk about how to find those using long division. And every once in a while, and this is very rare, we'll end up with a point where the graph actually does cross the horizontal asymptote. That will only happen in a middle section. It'll never happen on an edge. So we're going to talk about all these things, but basically it's a 3-step process. Sometimes there's some more advanced details in there. So the first thing we need to talk about is how to find the horizontal asymptote. We are going to focus on cases 1 and 2 where there are actually horizontal asymptotes, not case 3. And this is all based on the degree of the numerator and the denominator. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the line y equals 0, or the x-axis. If the denominator and the numerator have the same degree, then the horizontal asymptote is y equals a over b, where a and b are the lead coefficients of the numerator and the denominator. Case 3, if the numerator has a higher degree than the denominator, then we have an oblique asymptote, not a horizontal asymptote. So we'll talk about that later. Okay, we're not going to talk about that until later in the videos. Okay? So that's what we're doing here. So essentially the way this works is we go into each problem and we say, all right, what is the degree of the numerator? Well, the degree of the numerator on this first example is 2. The degree of the denominator is 2. So in this case, n is equal to d. They are both 2. which means that the horizontal asymptote is y equals a over b, where a is the lead coefficient of the numerator and b is the lead coefficient of the denominator. So that means that the horizontal asymptote is y equals 3/5. On the next example, the degree of the numerator is 1. There's no number listed for an exponent, so we would add a 1 to that x, and that would be our numerator. The denominator's degree is 2. Since the numerator is less than the denominator, the horizontal asymptote is the line y equals 0. On the third one, the degree on the top is 2. The degree on the bottom is 1. Since the numerator is greater than the denominator, there is no horizontal asymptote. It actually has an oblique asymptote, and we're not talking about that until later. Letter D, same idea. The numerator is 1. The denominator's degree is 1. Since the numerator is equal to the denominator in degree, our horizontal asymptote is y equals a over b, which would be 4 over 8. We would reduce that to get a horizontal asymptote of y equals 1/2. On letter E, the degree of the numerator is 0. There is no x. The numerator of the denominator, and I really should be doing this in blue now that I think about it, so let's get that fixed. There we go. The degree of the denominator is 2. Since the numerator is less than the denominator, the horizontal asymptote is the line y equals 0. And finally, on the last one, numerator's degree is 0, denominator's degree is 1. This should be in red. Pay attention. Come on, Wills. Okay, since the numerator is less than the denominator, the horizontal asymptote is the line y equals 0. Very simple idea. Okay, so there's 6 good examples of how to find the horizontal asymptote. Next up, vertical asymptotes. Vertical asymptotes are also fairly simple to find. We will, however, need to have factored both the numerator and the denominator in order to check for vertical asymptotes. Now that's if possible. So, in the first example here, in example 2, the denominator is a factorable trinomial. It factors into x plus 7 and x minus 5. Nothing cancels from top to bottom, so we have 2 vertical asymptotes because vertical asymptotes are represented by values that this function is not allowed to include. Those vertical asymptotes would be the things that cause the denominator to equal 0, which would be x equals -7 and x equals 5 would be vertical asymptotes for this particular function. On the next one, we have the top factors into x minus 2 and x minus 3, and the denominator factors into x plus 7 and x plus 4. Nothing cancels, which means our vertical asymptotes are x equals -7 and x equals -4, the values that would cause the denominator to equal 0. On the third example, the denominator is a difference of 2 squares. It factors into x plus 3 and x minus 3. Nothing cancels top to bottom, so our vertical asymptotes are the lines x equals 3 and x equals -3. Again, those are the values that would cause the denominator to equal 0 and would cause division by 0. Now this last one, this does not factor. X squared plus 4 does not factor. In fact, x squared plus 4, if we found its zeros, what it's equal to, that would be 2i and negative 2i. So this has no vertical asymptotes because the denominator's roots are not real numbers. Okay, these are complex numbers. They're complex roots which do not show up on a normal graph. Okay, now once we have those asymptotes, what we're going to do is we're going to see how many sections we've created. Which is based on the vertical asymptotes. And we'll talk more about this in a minute, actually in the next video. But when we have an outside section, outside sections need to have 2 points graphed each, and middle sections need at least 3 points. And on occasion, we may actually need more points than this. So it's sometimes, for special case stuff, we may have to do more points than I'm stating right here. But that's the minimum number of points that we would need to do for each section. When I'm talking the outside sections, I'm talking about the part to the left of the last vertical asymptote and the part to the right of the final vertical asymptote. And any middle section would be between vertical asymptotes. All right, we're going to stop the first video here and start up a second video for the actual graphing process. Thank you very much for your time.